Okay, next I really won't even argue this case because I think it is pretty easy that if you have any class of ordinals, then the intersection over that class is also an ordinal. All you have to do is show that this intersection over any class of ordinals is transitive in a well-ordered set. That will be pretty simple to do. Also, the intersection over a class of ordinals will be included in that class of ordinals. Well, now that we know it's an ordinal, and definitely the intersection over the class is a subset of that class, you can quickly get that it is included in the class. Okay. The next property is really the one where I'll devote some more substantial proof to it because it, I think, is a bit harder than the rest. This is the fact that the intersection over a class is equal to the infimum of that class. So to show that it is the infimum, we have to show that it is a lower bound and, in fact, the greatest lower bound. So we start with showing that it is a lower bound. Take anything in the class. We would like to show that the intersection over the class is less than or equal to this alpha in the class. Well, we know that certainly the intersection over the class is a subset of alpha, given that the intersection over the class is, so to speak, the least subset of the class. Not hard to show that if you pick alpha in C and therefore alpha a subset of C, that therefore the intersection over C is a subset of that. Okay. From here, we either get equality or a strict subset, and if we have a strict subset, right, the equality would be adequate. But if we have a strict subset, then we get inclusion, and then we get the less than relation, which shows that the intersection over C is less than or equal to alpha. Okay, now we will see that this intersection over the class is the greatest lower bound, so we suppose that we have some beta, which is also a lower bound for the class, and we would like to show that beta is less than or equal to the intersection over the class. We assume that beta is less than or equal to everything in the class. Well, that means it's in every element or equal to that element. And from that fact, we can, if beta is included, we know that therefore it is a subset. Therefore, beta is a subset of every element. Well, that just means that it is a subset over the intersection of the class. Equality would just get us an even simpler case to argue, or in fact the same case, really. From this, there are really just the two scenarios that either they are equal. We know that when you have the subset relation, you either get equality, or if it's strict, it's a strict subset relation, then that immediately implies inclusion, and therefore the less than relation holds. So there you have it. The intersection over the class is in fact the infimum of the class. The rest continued in the next video.